All right, so tonight we're taking some notes for Unit 3, and we're going to start off with something familiar, parallel lines. And we're familiar with parallel lines, but we're going to get another definition to distinguish them from another type of line that we see. So parallel lines are coplanar lines that do not intersect. So let's say, for example, I have here line AB, and parallel to line AB is line CD. And we designate that lines are parallel by drawing these arrows. And sometimes you see them written like that, sometimes they're filled in. When you have two arrows like that, that means they're parallel. So arrows are used to indicate that they are parallel. And we can write this symbolically by saying that line AB is parallel to line CD. Okay? And we already know the symbol for parallel. There's our symbol for parallel. All right, so we talked about parallel lines. Now let's talk about parallel planes. Parallel planes. Okay, so parallel planes, just like parallel lines, they do not intersect. And when you draw them, they kind of look like shelves hovering over one another. So let's say that that's plane J, and then maybe over here we have plane K. All right. And we designate them by saying plane J, we're going to pretend that's a script J, is parallel with plane K. So we still use that same parallel symbol notation for planes, same thing as with lines. So another type of lines that we have are skew lines. So skew is a word that we haven't really used so far this year. So skew lines. So parallel lines are coplanar lines that do not intersect. Skew lines are non-coplanar lines. Non-coplanar lines. So they're not on the same plane, that do not intersect. So like traditional parallel lines, they don't intersect, but skew lines are not even on the same plane. So a picture that we could show this is thinking about a rectangular prism. Okay, so let's say we have a rectangular prism. And you can try to draw this. It doesn't have to be as pretty as my drawing, because my drawing's oh so pretty. And let's say we have this W, and then V, and then U, and this is point T. Then let's say S, R, Q, and P. So let's identify some skew lines in that plane. So here's some examples. So lines that are not on the same plane and they do not intersect. So let's see. How about line TP? Well, VR, those are not on the same plane and they don't intersect. So line TP and line VR. Let's find a different pair. You could also say maybe WS and RQ, because even though they don't look parallel, they don't have to really look parallel. They just have to be non-coplanar, so they're on different planes and they cannot intersect. So we have line WS and line RQ. Can you come up with any more? Yeah, absolutely. Maybe we have, let's highlight one more. Maybe we have WV and UQ. So WV and UQ. And there's even more on this just for our examples. We're going to stop there. All right, so this unit is all about lines, so we're going to be talking about transversal. So there's our next word, transversal. And a transversal is a line that intersects two or more lines. Okay, so it intersects two or more lines. So let's say we have line L here, and then we have line K. A transversal would cut through those two lines. And it doesn't have to do so at any specific way. Let's say this is line T, but it intersects those two lines at 2 points. So here's an example. Line T. So transversals are actually really important to us in geometry because there are angles that are formed by them. So looking at our figure, this actually formed a bunch of angles. We have angle 1, angle 2, angle 3, 4, and then we have 5, 6, 7, 8. And we can actually use those angles to determine relationships between them. You can prove things with transversals, and we're going to name these different types of angles and their relationships. So we're going to use this same image here to go over different types of angle relationships. So the first one is corresponding angles. Corresponding angles. I'm going to abbreviate angles. And corresponding angles are angles on the same side of the transversal and in the same position. Okay, so angles on the same side of the transversal and in the same position. Well, what in the world does that mean? Well, they're on the same side. So that means, like, if this is our transversal T, let's talk about on the left side. Okay, well, on the left side, we have 1 and 4 and 5 and 8. If they're in the same position, like, let's say number 1 is above this line L, and the one that's above K on the left is 5. So angle 1 and angle 5 would be corresponding angles. Similarly, we could think about the angles on the left side of the transversal, but maybe underneath each line. So underneath L, underneath K. So on the left side underneath L, we have 4. On the left side underneath K, we have 8. So we have angle 4 and angle 8. Other pairs of corresponding angles in this picture are 2 and 6, angle 2 and angle 6, and then lastly we have angle 3 and angle 7. The next type of relationship we have formed by a transversal are alternate interior angles. Alternate interior angles. So alternate meaning they're switching left and right, and they're interior angles. So they're interior angles, they're non-adjacent, and they're on opposite sides of the transversal. So interior, we know that already. They're non-adjacent, that's important. Non-adjacent. So they're not right next to each other. And they're on opposite sides of transversal. So opposite sides. So they're on the interior. So that means they're somewhere in this area. They're on the interior. And they're on opposite sides of one another. So maybe we could say angle 3 and angle 4 because one's on the right side and one's on the left. So angle 3 and angle 4. And we could also say angle 4 and angle 6. And I just realized I wrote angle 4 wrong. It should not be angle 3 and angle 4. It should be angle, come on. It should be angle 3 and angle 5. Sorry about that. So we talked about alternate interior. Let's talk about alternate exterior angles. And those are going to be kind of similar. So they're alternate, so they're not on the same side. They're non-adjacent. They're non-adjacent. They're on the exterior of the parallel lines. And they're on opposite sides of the transversal. I'm going to abbreviate that. So if they're exterior angles, they're going to be on the outsides, the exterior of the parallel line. So we're looking at 1 and 2, 8 and 7. And then they're alternate. They're on opposite sides. So if 1 is on the left side, it will match up with 7. So angle 1 and angle 7. Angle 2 and angle 8. All right, last part of notes, we have consecutive interior angles. Okay, so consecutive interior, so obviously they're on the interior of the parallel lines. Okay, and they're consecutive, so they're on the same side as of the transversal. So same side of transversal. All right, so they're on the interior, so we're looking at these lines in between the two lines. I'm sorry, these angles in between the two lines, and they're on the same side. So 4 and 7, they're both on the left, so angle 4, and that's not a 7, that's a 5. I'm moving too quick here. And we also have angle 3 and angle 6. And those are our consecutive interior angles.